All right, all right. So this is, I believe, week 5. Don't quote me on that. But regardless, this is Threat Intelligence Week. The challenges are, I don't want to say easier, but I don't know. They definitely didn't take me as long to go through, and I don't think that they'll take that long tonight. Um, you know, either way, we are going to go through them, and yeah. Let's start off. People may trickle in as the night goes on, and that's okay. When they come in, we'll acknowledge them, and then we'll move on. So anyway, let's start off with the SOC101 challenges for the MITRE ATT&CK Challenge 1. And this is, again, underneath the Threat Intelligence section. And the instructions say, prompting an active incident response scenario at Permalink Software, the SOC team noticed an unusual spike in traffic from one of their endpoints, communicating with a known malicious IP address. This activity was flagged by the Network Intrusion Detection System, NIDS, and correlated with other indicators of compromise found in the threat intelligence feeds. Your task is to use your knowledge of the MITRE ATT&CK framework and TTPs to help guide the team through identifying and reconstructing the attack kill chain. By doing so, the SOC can better understand the nature the nature of the compromise and formulate a response plan. Awesome, awesome. So we're going to be dealing with MITRE, and I believe all of the questions are going to be found on attack.mitre.com, attack.mitre.org. Cool. So the first question is, the investigation revealed that a large spike in network traffic originated from an external IP address. The majority of this traffic was generated by a suspicious user agent in its Mozilla /5.0 compatible Nmap scripting engine and appears to be aimed at identifying vulnerabilities. What is the idea of this specific sub-technique? So, I mean, of course, we need to start looking into Nmap, and luckily they have like this beautiful little uh, I don't know, search feature. So hopefully that'll assist us in locating these techniques a little bit faster, I hope. Let's just search for Nmap on the page. Seeing a lot of Nmap here, but I'm not seeing what we would expect to see. Network service discovery, network sniffing, see procedures, mitigations, detection, F Nmap. No Nmap on this page. Enterprise. So this should be reconnaissance, vulnerability scanning, Nmap, no Nmap, active scanning. Hey, how's it going? How you doing? How you doing? Welcome in. I just started. This is question 1. Also, you're muted currently. But anyway, so I'll just go back to the question real fast. So we're looking for the sub-technique, the ID for the sub-technique. Um, oh, you don't have permission to speak? Excellent. Okay, one sec. One sec. So my thought was, it's during the reconnaissance phase. I thought it would be identified as active scanning. We can look at these sub techniques, but scanning IP blocks. And I thought additionally that I could like find it by searching for Nmap, but I guess not. We're not doing wordless scanning. This is like brute forcing directories and whatnot. Um, network traffic data sources. Map. Wonder if it would be easier to search for user agent. Emails. That's it. Go back to Nmap. Network service discovery subtechnique. I just made a bookmark. Let's come back in here. Say that again?
Things on there was just straight up called Lucifer.
Oh,
Yeah.
good stuff.
It's ominous.
Pure evil. Yeah.
That's my boy, Blue. I don't know that that's a freaking sub-technique. Is this a sub-technique? I think this is a sub-technique. Dot, blah, blah, blah. What else can we... Nmap, scripting. Let's try this then. I would still think that it's reconnaissance, and it's vuln scanning. Let's see if this is it, and it's not. Majority of the traffic was generated with suspicious user agent Nmap and appears to be aimed at identifying vulnerabilities. What is the idea of the sub-technique? Active scanning, vuln scanning, network, traffic content, monitor and analyze traffic patterns and pattern inspections associated to the protocol. This is a detection. Perhaps it wants the whole thing. .002. That was it. Okay, so it was that makes sense, right? Active scanning, vuln scanning. I really just thought that it would show us the detection, but I suppose that's not the case. These scans may also include more broad attempts to gather victim host information. Anyway, on to the next one. What is the name of the main technique that this falls under? Reconnaissance? Is that what it's wanting? Active scanning, maybe? What is the main technique? Recon? Enterprise?
I would imagine recon. Maybe it's wanting it more specifically.
Maybe. Okay, it's active scanning. Okay, so I would think that as well, but I guess not. I guess the idea is
Be as specific as possible.
right. So each of these sub-techniques falling under the active scanning technique, which falls under the reconnaissance phase. The SOC later discovered that the adversary exploited one of the organization's external software applications through a SQL injection vulnerability. What is the MITRE technique ID that led to the attacker's initial access? SOC later discovered that the adversary exploited one of the organization's external software applications through a SQL injection vulnerability. What is the MITRE technique ID that led to the attacker's initial access? SQL injection I guess we can search for SQL injection, but we might be able to search for all injections.
Is there not just like a dedicated SQL injection tab on the left?
I wouldn't think so, but we can go to techniques, enterprise. It would be under the initial access, I think, and content injection.
That feels right.
And network traffic. Monitor unusual. These are detection events. Tactic, command and control, subtechnique, no subtechnique. Do you think that it's this? Command injection, content injection? SOC leader discovered minor attack, SQL injection vulnerability. What is a minor technique that led the attacker's initial access?
No.
Maybe not that. But something else with SQL injection is like, while it, you are like exploiting SQL, a lot of it. Do they say remote code execution? Visual external application through a SQL injection vulnerability. What is the technique that led to the attacker's initial access? Enterprise. Automated exfiltration. Browser extensions, automated exfiltration, traffic duplication. Compromise. Exploit public facing application. I guess we can just look at T1190. Okay, so that's what it was.
Oh wait, go back if you don't mind.
Into here?
Okay, I just wanted to see. Okay,
Yeah.
got it.
So it's an enterprise technique. It's identified as T1190 for exploit public facing application. Use deep packet inspection to look for artifacts of common exploit traffic, such as SQL injection strings or known payloads. For example, monitor for successively chained functions that adversaries commonly abuse, i.e. gadget chaining through unsafe deserialization to exploit public-facing applications for initial access. In AWS environments, monitor VPC flow logs and or elastic load balancers, ELBs, logs going to and from instances hosting internally accessible applications. Cool. Question 4. It was later discovered that the SQL map tool was used to automate the process of detecting and exploiting the SQL injection vulnerability. What is the MITRE ID pertaining to this piece of software? I wonder if that would be under tactics this time, but maybe not. SQL map. SQL map software. And it has this ID? Is that what it's asking though? What is the MITRE ID pertaining to this piece of software? There it is. S0225. SQL Map is an open source penetration testing tool that can be used to automate the process of detecting and exploiting SQL injection flaws. It's pretty cool. So like, if you haven't used it before, you can like capture your log request, like a login. Like if I were to log in to try hack me here, if I have like a proxy or something open, I can take the request and I can put it into a just a text document, and then with SQL Map you can just set it as like the whole thing. You can like use it. I think it's R, just like -R and the request file, and then add some other flags like risk levels, because it'll try like more, I guess, risky techniques. But it's really quick and very effective. But I don't know. It's a very strong tool. After achieving remote code execution through the SQL injection vulnerability, the attacker created a remote reverse shell on the server by initiating a command.exe process. What sub-technique does this relate to? Initiating a sub-technique, command sub-technique. Tactics, enterprise, persistence, perhaps, maybe? Graphics, privilege escalation. It's not. Created a remote reverse shell on the server by initiating command.exe process. Is it command and scripting interpreter? Maybe. PowerShell, Windows, Command Shell? Here we go.
That feels right.
Yeah, I believe it's this. Because we're specifically using cmd.exe.
Right.
And it is awesome. And then the
Not so
attacker.
bad to find your way.
Hmm?
It's not so bad to find your way around once you actually know what you're looking for.
Yeah, yeah, yeah. You're right. Yeah, yeah. Especially like if you just think about like the phase that it is, and then what's actually happening. I guess it
Right.
is easier. Also, you know, and some of the other ones, the keywords really helped.
Sure.
The attacker escalated privileges by impersonating an administrator using security token and abusing the SE impersonate privilege. According to MITRE, what is one of the API calls that can be monitored to detect this behavior? So we're looking for a detection this time, and we can probably just copy SE impersonate privilege and search for that. I assume. Nope. Access token manipulation. Token impersonation and theft. We're interested in detections. And what is it asking? What's the question? What is one of the API calls that can be monitored to detect this behavior? I imagine we can just search for API. Any standard user can use the run as command and the Windows API function to create impersonation tokens. Not that. We want it in the detection. So there are many Windows API calls a payload can take advantage of to manipulate access tokens. Log on user, duplicate token, impersonate logged on user. I assume that we could use any of these for detection. According to MITRE, which are the one API calls that can be... What is one of the API calls? We can try... Wrong. Monitor API calls loaded by... There are many API calls can be taken advantage of to manipulate access tokens, e.g. any of these, right? Oh. Well, that makes sense, right? Impersonate
That
logged on
does.
user,
Yeah.
impersonate.
Bit on the nose.
Yeah. Awesome. And then during the initial live incident response triage, a responder noticed that an existing Windows service had its image path modified to point to the attacker's malicious reverse shell payload. Point to the attacker's malicious reverse shell payload likely to establish persistence. What is the idea of this sub-technique? Windows service had its image path modified to point to the attacker's malicious reverse shell. Okay. Techniques, enterprise, persistence. Looking for services, server. I suppose it could be something there. Do we see services? Event trigger. External remote services. Modify the image path to attacker's remote shell payload. To point to the remote shell payload. I think of this, I think of unquoted service path vulnerabilities. And modify system process. Maybe. Oh, Windows service. Is that what it wants? What is the idea of this sub-technique? Create or modify system process Windows service. Awesome. What was this under? Create or modify system process inside of a Windows service. And adversaries may create or modify Windows services to repeatedly execute malicious payloads as part of persistence. When Windows boots up, it starts the programs or applications called services that perform background system functions. Windows service configuration information, including the file path to the service's executable or recovery programs commands, is stored in the Windows registry. And 8 says, around the same time frame, endpoint logs in the SIM reported that the system's endpoint detection and response tool was turned off and disabled. What sub-technique ID is this? So we're looking at evasion. So defensive evasions. And they turned off the EDR solution, impair defenses, disable, downgrade, disable, modify, impersonation, disable, or modify tools, maybe? Let's see what this says. Disable security tools.
Bypassed antivirus.
Do you see that in here?
Prevention system on the right side.
Oh, host intrusion prevention system, logs, system signature-based detection, antivirus.
Seems fitting.
Indeed. And it is. The CCF32 software, which we'll just go ahead and take that, was transferred to the host shortly after the initial compromise. What tactic is this software likely used for? Tactic, enterprise. We just search for this instead. Of course we can. Is data collection malware that has been used since at least February 2019. It is malware. So is it exfiltration? What tactic is this software likely used for? Should it tell us in here? Tactic. Automated collection. Oh, C2. This is a C2 framework. Command scripting, Windows command shell, exfiltration over unencrypted non-C2 protocol. I wonder if it's going to take C2. Command and control. Okay. Guess I'm wrong. Is it data collection malware that has been used since this time? Then is it exfiltration? Software transfer to the host shortly after the initial compromise. What tactic is this software likely used for?
It doesn't feel like a tactic. That just feels like something you're doing, you know?
I assumed
Maybe it's
exfiltration.
under exfiltration, but
Software was transferred to the host shortly after what? After the initial compromise. Collection. Adversaries gather information and sources. Information is collected from that. collection. The adversary is trying to gather data of interest to their goal. And what's in my clipboard?
There's one for automated collection
It,
under CCF32.
it may just be collection, and it is. Yeah. I was just, suppose, looking at the wrong thing. Tactic. Under where though? You were looking at what? Collection.
Collection, automated collection. Like if you.
There it is.
Yeah.
Yeah.
And then if you go into that, it says. CCF32 is on there. On the list.
There it is. Has been used to automatically collect files from a compromised host. After staging sensitive data, files, and intellectual property, the attacker exfiltrated the data by pushing it to a public GitHub repository. What mitigation ID could the organization have implemented to prevent the use of unauthorized external services? Logon sessions. About the certain pages. Look at this. That doesn't seem right. So we're looking for offensive exfiltration. Exfiltration over other network medium. Made it
Over
out.
web service.
You see that? Okay. See that? Detection. Network traffic. Wow, what were the other options? Application logging. Review logs for SaaS services, including Office 365, Google Cloud to detect configuration of new webhooks. Monitor executed commands and arguments that may use an existing legitimate external web service. Monitor for files being accessed by an existing legitimate external web service to exfiltrate data. Monitor for newly constructed network connections to web and cloud services associated with abnormal or non-browser processes. Let's try this. DS0029. Wrong.
I like the file one.
File?
They specifically say
Is it
exfiltrated.
Was it 2.8? 2.2? GitHub. Git legitimate. GitHub. Load more links. Defenses. Mitigations. Enterprise. Application. Audit. Network. State software. Vulnerability management. Vuln scanning. Restrict web-based content. Restrict use of certain websites. Block downloads, attachments. Block JavaScript. Restrict browser extensions. Okay, cool. So a defense is to just restrict users from accessing sites like GitHub if they don't have a need for it, I suppose. And then to complete the adversary's actions on objectives, the organization's public-facing corporate website was modified to display propaganda messages during the attack. What is the full sub-technique idea of this attack? So we're defacing a website. Defacement. Uh, sub technique. Internal, external defacement. Guess.
Yeah.
We made it. I think it's probably good to know um, how to navigate MITRE. I'm maybe like if it came down to it, we could use it for attribution, like after, um, or maybe like even during vulnerability, like trying to manage, I guess like an incident on the network or something. Um, what do you guys think about MITRE specifically and its usage? Like, when would you see yourself, coming in and using the attack.mitre.org? If not, when
Or after reports,
Yeah,
after report for specifically attribution.
incidents.
Yeah.
I don't see myself using it prior to knowing anything like that.
Yeah. Yeah. The only other thing the only other time I guess I could see it being used, and I'm sure that we're not considering something, but is during like a threat hunting, where you're kind of like
Mm.
looking through a network
Proactive.
and yeah, right, exactly. Like maybe you're trying to, I don't know, you see some funny looking stuff, and then it kind of helps you to say, okay, well these individuals are looking at or tend to like do uh, this thing at this time, whatever, during this phase, and then maybe it would give you something to look at after. Um, Before, can we look at the matrices? Is that everything? Right. Like, I don't know. You find something that's like a scheduled task, and it's doing something specific. Um, so coming in and actually like, I don't know. I guess what I was thinking is that if that were the case, then you could probably come in and it might help you find out where to look
You could put it
next.
into the official terms and then go from there.
Yeah.
There might be like a sub
Yeah, like maybe there's like a technique,
related
and
attacks or
then
something.
yeah, you can
Mm-hmm.
identify like I don't know, an APT or something. And they usually work this kind of way or that kind of way. And then you can just find, I don't know, dig deeper into your network and logs to track whatever was happening.
Only we
Anyway,
had a sock.
I know. Not happening. Not happening at all. Um, I thought this bit was pretty fun. The Yara stuff. And I say fun. Yeah, I guess I would say fun. The It's like you could, if you wanted to like practice this, like creating these Yara rules, you could just like, I don't know, download malware from Malware Bazaar or VX Underground or something, and just see what it does, do some static and dynamic analysis, and then you could then create your Yara rules to um, detect it ahead of time or like in the moment, as it's running, and then generate, I don't know, rules to stop it based on those detections. Anyway, the Yara Challenge 1 instructions are you're a SOC analyst at Meowware Labs. Over the past few months, your team has accumulated a significant backlog of malware samples. These samples have been collected from various sources, such as phishing emails, suspicious downloads, and through user reports. To address this challenge, the organization has recently invested in enhancing its malware detection and threat intelligence capabilities by adopting YARA, yet another redundant acronym. Uh, your task is to leverage your newly acquired Yara expertise to develop and refine Yara rules to better detect the threats and artifacts associated with these malware samples. And then the challenge directory is O5 Threat Intelligence Yara Challenges. I think that I have it up already. I do. And I'll probably work out of this folder. Can you guys see very well? How well can you see? Is that too big?
Good. Yeah, that's good.
Okay. I make the window a little bit different
Gotta get my
or bigger.
bifocals here.
Hey, boy. It's hard to. I know it's hard to see some text sometimes, so definitely want to make it.
No, I was
I
just kidding.
definitely want to make it visible.
Mm.
So the first thing we're going to do is run strings against the hawkeye.exe.meow command executable. What is the name of the JPEG file that is referenced? And I think that we can just grab, so we can strings for challenges, samples, Hawkeye, and then we can grep for JPG, and there we go. This is our
That's our boy.
JPEG file, and then use the name of the JPEG file to create a YAR detection rule for any executable files that match this string identifier. Run it against hawkeye.exe.meow. What is the offset location of the matching detection? So Yara, the application, has some commands that we'll use during this. I'll probably only use this. Print strings, print matching strings, and R for recursion. There are other things, like count the number of times that something matched in a file. I don't know. Those are probably the only things that I'll be using this time. But now we need to generate some rules. So this is the general way that Yara rules are formatted. They start off with a rule, and then you have the name or the, what should we call this? It has a name. It has a name.
Almost feels like sequel.
So it's actually YAML. Yeah.
I guess I've not done that one.
Mm-hmm. Well, I sure wish I knew exactly what that was called now. Function? I don't know. I guess we can call it a definition for now. But it's going to start off with some metadata. I think that this is optional, but I think that also the standard is to input this type of information, a description about like what the rule is doing, who you are, when the rule was created, any references that you have related to the malware, any tags. So like these had something to do. This was when when he was making this, like going over the meta descriptions, he specifically was talking or like mentioning tags that he would use around Mimikatz, because you can dump LSAS, it's a Windows binary, and it's malware. If we had a hash ID of the executable, what I meant to do, SHA-256 sum. Awesome. This, so we could use this in our hash value here, and we could add, the other types of hashes. So SHA-1, MD5, and then SHA-256. We could give it any kind of ID, and then what version this is, and then we're going to start defining strings. So he was actually giving these names, but I saw the way that this like very prolific defender, his name's Florian Roth. I've actually, I don't know, I'd heard about him from Twitter. initially, and you can just see him. He's like always creating Yara rules. I imagine he has like a bigger role in them. Like I don't know, maybe he's a creator or something, but I know that he makes a huge amount of rules for detecting, different versions of types of malware. And then we'll set a condition. So Yara has these modules, Yara that we can import. So because we're going to be looking for an executable, we can use the import PE. Yara rules. I know that this search gets me to the documentation. But we can go down to modules, and then we're going to be using the PE module. So we start off by importing PE, and then the PE module allows you to create more fine-grained rules for PE's files by using attributes and features of the PE file format. This module exposes most of the fields present in a PE header. So if we look at I wonder if this will be in there. Well, I guess really, let's do this. Do I have hex dump? Hex dump less. I guess that's what that is. 5A4D. Let's open up CyberChef. And then if we do strings on it, out of that. You should see at the beginning some identifiers, things that are always there. So I don't see the MZ, but we do see this. This program cannot be run in DOS mode. So we could detect on this string, what was it? 5D4A, maybe, from hex. Five A4D. 5A4D. So the reason that they're in reverse is because this is little endian, so we need to take that and run it around. 4D5A. So executables start with this. This is just how they're identified. But anyway, so this, like, instead of having to import all these different detections, or like match on all of these different header fields, it's kind of all rolled into this PE module. So we can just import PE into our rule here. And then what we're interested in this time is the string here for the JPEG. So we are going to set a string variable, which is denoted by the $, and then I don't know, whatever you want to call it. And then we are going to set that to this string. And then the connection that we're going to use is we're going to call the PE function, and then I think it's is PE. And then first things first, we're saying that the conditions must be met. It must be an executable, and it must contain this string. So temp1e2a.jpg. If we save that, and let's actually see what our question is. I think I've lost the plot. What is the offset location of the matching definition? And let's do Yara. Actually, Yara S. We need our rule. Where are we? Rules TCM.yar. Unexpected identifier, non-ASCII character. What did I do wrong? PE.isPE and URL. Is it the spacing that's wrong? Import PE, meta, detection, string, for closing, PE.isPE, and I feel like that condition makes sense. Now I'm a little curious. Okay, so it's that I'm a big dummy and was putting them in reverse. So I guess we have to call the rule first, the string that it's matching, and then we're going to call the binary. So we can see that it's matching at this offset, 0x1115D, and it's matching our one string, our S1 string. So there's that, and then what is the decimal conversion from base 10 equivalent in this, of this hexadecimal format? We can use printf for that. I think it's %D, and then a new line, the hex value, and then this is it in decimal form, 69981. I think that it would work without that, but anyway, we're just gonna convert this hexadecimal into decimal. Run the rules, rule.yara, file against the entire samples directory, which file was detected. So yara, challenges, samples, rules, and then we're going to run it against entire samples directory. So we need to add the recursion flag, and then we'll see that we're matching these four. Run the rules, file against the which file was detected against the entire samples directory. Which file was detected? Do I not want recursion? I guess it doesn't matter, does it?
There's only one file.
Oh, you're right. These are the strings that it's matching. Good on you. And then using the Yara rule, on the previously identified binary, how many individual string matches were detected? 4. 4. And then run the strings command on free YouTube downloader.exe.meow. What base domain name repeatedly appears in the output? So we can run strings on the challenge, samples, this, and then how do we do this? I want to grep for this to make it easier, but there's like a special way to do this. So here's what we know that we're going to see. We're going to see a period, and then on either side there's either going to be numbers or letters, right? So this should allow us, and hopefully this is even the right way to do this. But what I thought would happen here is that it would only give me. I thought it would only give me A to Z and periods, but I guess that's not the case. And maybe because this file is not too crazy, maybe it's not even necessary. We're just looking for .com, .org, et cetera, et cetera. Right? What is the base domain name? Yeah. And we maybe even be able to make it longer. Um, I guess it could be shorter. Maybe we just do 5. So anything longer, or 5 or longer, right? Downloader.link. Oh, okay, here it is. Support at YouTube downloader new.com. I assumed that it was there last time and I missed it. I am really curious about this now. Be like that? Hey, that's how you do it. We could have just done
Nice.
this. Awesome. So again, we're searching for strings that are, I think, at least 10 characters long in this file, and then we're grepping for this pattern. So any character A through Z with a period in between another uh, any
A to Z.
character A to Z, yeah.
Yeah.
Does it want the www? It doesn't. Use the previously identified base domain name, create a YAR detection rule for any executable file that matches the string identified. Run it against free YouTube downloader.exe.meow, binary in order of appearance. In the file, what are the hexadecimal offsets of the 2 matching detection strings in order of appearance? So we can do this. Not that it matters. We don't have to do this. If you want to comment in YAML, you can just do the ticks. So we will make another one and we'll make it equal to this. And then honestly, it should just work. Yara, actually, let's clear this. Yara, challenges, samples, rules. Actually, it's in rules, TCM, like S, challenges, samples, for YouTube downloader. There we go. It did a detection on the string. How does this compare to the snort rules so far? It's like significantly different. Of course, they're doing, different things for the most part, but like basically identifying a string that appears in the malware, um, and then in your YAML file, looking for that string. And of course, we have 2 conditions, like it is an executable, and it contains a string. So it's a little bit.
I definitely would want to practice both way more than I have. I don't
Yeah,
feel remotely comfortable with either snort nor this.
I've spent no more time doing snort at all.
Yeah, you got burned last time, huh?
Man,
That
it,
sucked.
it just takes so long, and it's
It
like
does.
I don't know. I'm sure that learning it would, everything is like that though, right? If you learn it,
Hmm
you just it's so much easier. Um, but I don't know. I feel like this has been pretty easy to pick up, just off
It
of.
feels more intuitive.
Right, exactly, exactly. So thinking back to the
Logical,
pyramid
at least.
right, yeah, exactly. And there are just so many. I'm sure that there are snort examples, but I don't know. There are a ton of examples of Yara rules. So um, pretty easy to just look back and see how people are doing it in standards. But thinking back to the pyramid of pain, so like, let's say I'm an attacker and I create an executable, a piece of malware. If you're only detecting on the hash, and I change even a single byte, like character, in the malware, um, the hash is totally different. So that doesn't cause me a lot of trouble. I can just do some kind of like, I mean, I could just go back in, uh, change it, and then recompile the code. Um, so it's not too terribly difficult. Um, but that's kind of what they're referring to in pyramid of pain. Is like how hard is it for the attacker to obfuscate um, whatever it is that they're doing, and that's kind of where they start adding in like the tactics, techniques, and procedures because um, you know your methodology is pretty well your methodology, and you tend to do things in certain order. You tend to use certain tools, and so it's a lot harder to change like your behavior than it is to just edit a string or a value. Um,
Right.
and just it causes more pain when you begin to like identify these APTs like behaviors along with their tools. Um, it would be quite trivial for an attacker to change the name of the program and any references to the previously identified domain name. However, consider the host artifacts that this tool inherently interact with to function. Which interesting or unique registry value is found in this string? So, which interesting or unique registry value? Um, so if we think about registry, I don't know if I should pull up my own registry, but probably not. The first thing that comes to mind is system, and does it tell us what we're supposed to be looking at? Does it still want us to look at the free YouTube downloader? The pyramid of pain. However, consider the host artifacts tool inherently which interesting or unique registry value. Let's just see. So we'll strings it again. We'll give it a limit. We'll call it 10, and then we'll just move up. Here's the registry value. I guess Windows current version. Maybe it could be doing some kind of persistence here with the run value, but that's not right. This looks right. 1, 2, 3, 4, 2, 3, 4, but it is not that. That's the same thing that I just saw. I'm just happy to scroll back down. If we could just search for system and software. There's another one, software, but it's Microsoft.NET Framework Policy. Software, uninstall value, software Microsoft Windows. Borland, Delphi, RTL. This follows the same format that they're looking for. And I wonder if this will show anything. .com. What if we close it? software Borland Delphi RTL, which is the exact same thing that we've been looking at the whole time. So anyway, let's just paste it in and see what happens. That is it. I guess that's unique. Oh, okay. I get it. So it's because it's unique that we could use it to detect because oh, it just is. It's just unique. There are probably very few extracted strings. Filescan.io. I'm curious what this does. I don't want to. What is this going to do? Items, registry section, code, ILC registry. Spyware forensics with reversing and static analysis. Lineage. I kind of wanted to know what this is. Trojan is in the software I am developing viruses and web. Instead of software Borland Delphi. Blah, blah, blah. Delphi 5 logging tool. What happened to Borland Delphi? Delphi is an evolving program language. Borland Delphi software. Screenshot of Delphi 1.10.0 with a visual for editing. Delphi includes code editor, visual designer, integrated debugger. Borland as a rapid application development tool for Windows, successor to Turbo Pascal. Added full object-oriented programming to existing languages. I guess the idea is that it's just unique. It's unique enough to be able to capture or mark it as a string to locate. Creating a YAR rule only to detect the registry key and create a YAR rule only to detect the registry key and run it recursively against YAR challenges folder. What other files are detected? Only provide the name. So we can do this. We're gonna have to escape these back tick is what I'm gonna call it. What would you call this? This character. Backslash? There we go. It's a backslash.
Yeah.
Yeah. Cool. So now we can run this again. Yeah, that's right. But we want to run it on the entire folder, right?
Believe so?
Entire Yara challenges folder. So we need to add the recursion flag. And we have this as a file. And my assumption is that what other file? So the assumption here is that it does not want the free YouTube downloader.exe because we know that it's in there.
Yep.
We did not know that it was in these two. And it's absolutely capturing on the string at different offsets. Create a YAR rule to detect any GIF89A files under 50 kilobytes in size. Run recursively against Yara challenge folder. Which files are matched? Only provide the name of the file and not the full path. So the cool thing here is that we can get the magic bytes. So even though we have this, let's grab it. We can get the magic bytes for this. Magic bytes. List of file signatures. And we can capture on both if8 and 9, the string, and the hex values over here. So to do that, we can we'll get rid of this, and we'll say $S1 is equal to this, and then we have a $S2 is equal to, and so when you're doing hex values, you need to wrap them in these curly brackets, and the inside will highlight like that. So the idea here is that one, it's an executable. I'm moving the P around on accident, and it contains either GIF89A or these hex values. So this should detect on string 1 or string 2 and executable. So when we run it, what's ID here again? Idea of and under 50 kilobytes inside. So we need to do some additional pull stuff. So we want it to be like that, and we want the file size to be less than 50 kilobytes. And we actually may not need this. I don't think that it cares about it. Which files are matched? Yeah, so we're only going to detect on GIF89A and under the 50 kilobyte file size. Only provide the name of the files, not the full path. So then we're matching on these two strings, and it has to be less than 50 kilobytes and contain one of the strings. So to do this, we have 3. Yeah. Mantis.exe, this and that. Which files are matched? Which files are matched? Does it? I was a little bit confused because like on this one it actually had the format that it wanted, so I assumed it would include that here as well. But I guess not. Run it recursively against Yara challenges. Only provide the name of the files, not the full path. Are we having a crisis here? It is capturing on each of these. Did I say greater than? I said less than. Next question is, does it matter that it is an executable? And maybe this did remove one of them. So maybe it just, shit. Maybe it just doesn't want this one. Wrong? And here's the other thing. It's actually doesn't look like it's detecting executable. Maybe it is. Wrong. Create a YAR rule to detect any GIF8, 9A files. GIF8, 9A. File size is less than 50 kilobytes. What if we only matched on the one? Getting the same thing. What?
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 Cool.
No, what?
Sweet.
That doesn't make any sense. Does it? Alright, let's try this again. Let's get rid of this. That apparently doesn't matter. We're matching on either of these. $sign S2. And a file size less than 50 kilobytes. Learning the rule. cursively in challenges. I'm in Yara, challenges. Only provide the name of the files, not the file path. Yeah. It's really confusing, isn't it?
Whatever
If
works.
89A. Yeah, but it's just like this is here. So it really, I mean, this should be, I'm gonna go back and look at the hint after this, after we get done. Um, and actually, I have a copy of when I went through these the first time, on Sunday, Saturday. So I should have, I mean, hell, I don't know. Maybe I did something different this time, or maybe I did something different last time. It just seems like files cursively. I feel like we've matched each of these rules, and multiple things came back. So create a Yara rule to detect any over 50 kilobytes in size. Okay, we can do that just by editing the string. Cannot do that to be greater than 50 kilobytes. Running it again, and I'm just going to give it this one again because it doesn't seem to care about. Yeah, okay, it's fine. How can wait? Hold the fuck on. How can this be? How can this be both greater than and less than 50 kilobytes in size? You know?
Mm-hmm.
Here's a question. Does this cause problems? Again, let's just get rid of everything. It shouldn't. That should work. But I mean, hell.
That one gets rid of the exe.
Right. Good point. Good point. Good point. Is that, and was that our answer? That was our answer.
Yep. How does that change?
The change was the only change. Well, okay, let's go back and add this again because it should be able to do this or $2 and file size.
S2.
Right. I'm
What? Now we even have more.
right.
We have
There are
both of them
3.
now. Plus the
Right.
exe.
Hmm. Unexpected file size, expecting the end of the string. This or this. And yeah, what the fuck? I don't know. We'll go back and look at it later. But I feel like that or should work, so I don't know. Actually, maybe we can look at it now. Where is it? Or, writing our rules. This is probably not a great way to search for this.
Could you
String
do not over 50 instead of or? I mean, instead of and. I mean, I know that's literally the same thing, but
I don't know. We could try. No, it's still expecting an and here so that it can move. It knows to move to the next line, I think. Let's see. Any of them? Try that. Any of them. And That works.
What?
Yeah. So there must be something flawed by saying this or this and this.
Maybe since they're both the same, kind of. One and two
Right.
are technically the same.
Yeah, that is true. They are technically the same. Hmm.
Hmm.
Well, either way, that
All right.
seems to work. And then if we do the less than, we get 2 back. Still.
Hmm.
I mean, hell, it says that it has it in it, so I guess I'm a little confused there. Anyway, let's look for the next one. Research the file signature or magic bytes pertaining to open SSH private keys. We can just search that in our wiki page over there. What is a hexadecimal string hex signature that can be detected, can be used to detect that string? Here it is. So it's this, and it doesn't want that yet. What's it in here? And then we're going to create a YARA rule to match on that, and any executables. So we'll get rid of this, and we'll say and $S1 because we're going to change this be a hex string. Only provide the name of the file. Run it recursively against challenges. Cool. So we get 2. And it does look like it's giving us that the answer format that I expect to see when we see 2. And there we go. Cool. Now let's reset this because I'm really interested in seeing what that challenge or the hint was. For this one, yeah. Use the list of file signature reference to find the hex signature corresponding to the.
We knew that already.
Yeah. And I assume this is the same thing. It is. So we did both. Let's go and let's look what I did here. Or I guess I can pull it up in this. This rules old. So I guess I only selected the string and S4. Yeah. So I set the offset here as well. Did it ask us to do that?
I don't think so.
Which files are matched?
You were just being extra.
Guess so. Anyway, that's what this would be at 0. Saying it exists at offset 0, so at the beginning, the file, which I guess is more precise. I'm kind of interested. It was less than. Ugh. Copy this to be rules tcm2.yar. On line 37. Ah, I see. Well, it's not going to help me there, is it? This, and then we probably need to get rid of this as well. That seems right. And that pulls back just the one. So I guess
it's just looking at,
it's,
but you're also only looking at one at S4, which is just the one version of the GIF file and not the hex value for it.
Okay, well, that's a good point. That's a good point. Let's add, let's do this. Let's add both and just see what happens. Because what I'm thinking is happening is that maybe the GIF value existed at other offsets in the file, and maybe that's what our problem was. If shit, was it this one? It was the 9A. Guess we'll find out in a minute. 9A, yeah. Right. And oh no, or S5 at 0 and yep.
Get all three of them again.
Mm-hmm.
That's. What if you try any of them?
Any of them at 0 and blah blah blah. Returns just that. You may be right though. You right? Like I don't know. Maybe the these called do you think these are like logical operators? You think maybe that's what these are called? And or it's like that. We're calling them keywords.
Them.
And
wide.
Yeah, they have some funny keywords. Funny in that it's like, well, okay, what the hell does that actually mean?
Use them. Their keywords.
Them there. Hex strings. Double quote, backslash, carriage return. None of that. It's helpful. Any of them is interesting, but not. Not really what we want, I guess. Have an and. I want an and an or on the same line. Oh, here's what these. What did you said? Wide. Emulate UTF-16 by interleaving null characters. What? Yeah. Emulate UTF-16 by interleaving null characters. I don't know.
Yeah, I knew that.
Conditions are nothing more than Boolean expressions, as those that can be found in all programming languages. This or this, and this or this, and this. Just trying to like think about that. This or this and this. Oh, okay. There it is. So we need to group them, it seems, like this. Maybe?
Didn't like that.
I didn't. Oh, I see. No, that's should be fine. I thought.
Did it say on line 34?
Yeah. Unexpected at.
Maybe the at needs to be on a different line.
At 0. Oh, well, maybe, but maybe it needs to be included here. Yeah, cool. Okay. So we've got our greater than. Here's our less than, which is the one that did the goofy stuff. And here's the thing. Okay. At 0 or there we go. Because before what we were saying.
0 at each
Yeah, exactly.
string.
Yeah, and that makes sense.
Huh.
It's saying it's like it's either
interesting
this.
that you can't put the 0 at the end of the like behind the brackets to apply it to the whole. But we tried that.
Yeah. I guess it makes sense because I'm not sure how they anticipate these things, but you know, like in math, you do what's in the brackets
order.
first. Yeah, the order of operations. I assume it's something similar to that. Anyway, that's fun. I don't know. I like these. I think it would be kind of cool to just like go down a rabbit hole, yeah, of making them. It would just be fun, I think. The other thing that I had, well. Anyway, we'll stop this bit here, right? So this is the end of the threat intelligence section, and then you can go back and watch the VOD if you want to go back and look at the answers and how we managed to get there. And then this really cool analysis of us going a little bit deeper into why that one Yara rule did not work, and then that us realizing that we need to use are those called freaking parentheses? Why do I blank? These are parentheses.
Yeah, I did last week.
Yeah, these are parentheses. Okay, cool. Yeah, so you can go back and check those out. And we'll see you next week.